Infrastructure exploring Crossplane's full potential. So my name is Tobias. I'm a solutions architect at Upbound. First of all, a huge shout out to my friend Yuri and colleague Yuri, who is not able to join today, but I hope I can still satisfy your needs. So first of all, who of you guys are using Kubernetes? That's good. Hands still up. Who's using Crossplane? Who's using Crossplane in production? We still got one. Very good, very good. Thank you so much. Okay, so let's start. What is Crossplane? So Crossplane is your cloud-native control plane. It can be used to manage and provision all of your resources. So that means we can compose these resources into higher-level abstractions and give developers these as a self-service for provisioning their stuff. So it works a little bit different than your classical config management tool because we try to build APIs so people can actually self-service themselves. So Kubernetes is already a great control plane for containers, and we use Crossplane to teach it how to manage everything else. Cloud providers have been using this pattern for years, and now it's your turn to do the same. It's a CNCF project, and we're currently in due diligence for graduation. Just to give you a little numbers, like we have 2,500 plus active contributors. It's amongst the top 10% of all CNCF projects for PR authors. We have 850 plus PR authors, 400 companies contributing, 150 companies with maintainers. Our steering committee consists of members from Apple, Nokia, and of course Upbound. And we have lots of adopters in production and a very big scale. Some of them are Nike, Autodesk, Grafana, and the list goes on. The full proposal is here for you to see, so you can check it out if you're interested in that. So build your own platform API. As I said, we want to assemble granular resources from multiple clouds or pretty much from anywhere and expose them as a high-level self-service API for your app teams. That means you can take, for example, if you're running on GCP and you want to create a GKA cluster, it's not done by just creating a cluster. You also need to have a node pool, a network, a subnet network, or pretty much anything else you want to add on top. So we compose this as a single thing and offer it as a single cluster abstraction API with limited configuration to your developers for self-service. So you can hide as much of the complexity as you want and also include your own policy guardrails, your own opinions about how these things should look, and it's all abstracted away from the people who actually work with it and are not interested in turning all these knobs. And the good thing, it's all compatible with Kubernetes API, so you can use kubectl, you can use GitOps tools, whatever you like, and there's no code required. Doesn't mean you can use code, but it's just not required to get you started. So why Kubernetes? So Kubernetes is becoming de facto standard for deploying containers and services. It's declarative. It has a very good model for extending it. You can have custom resources. And the nicest thing about it, I think, is that its controllers reconciles the actual state with the desired state, and that completely eliminates drifts. Who was in the situation who ran a Terraform module against an old state in Git, and just to figure out that stuff just didn't match the reality, and you would go and need to find out who changed stuff here manually. So we can use that for infrastructure or pretty much everything that exposes an API to completely get rid of that. It's also a mature and battle-tested platform, and it serves RBAC, it's designed to auto-heal, and it integrates with GitOps tools, as I said. So you can give your developers access just to create the resources you want them to create. Of course, it also comes with a bigger footprint and a lot of complexity. But what we found is that with a bigger scale, this trade-off is very much worth it. And we're talking here about thousands and thousands of resources. Just to give you a picture on how the complete stack look like. So at the bottom, we have the Kubernetes runtime, which runs workloads, provisions ingress, has the RBAC functionality. On top of that, we have the Kubernetes API machinery, which has the custom resource definitions, Open API spec, and etcd as a persistent layer. Then the list goes on with the controller runtime, which emits events, which we can then watch. We can request from the API, and it does the reconciliation. Then comes Crossplane, because on top of that, we can manage any external API with a CRUD workflow, And on top of that, we have our controllers, which run the custom logic. So the basics. Let's start with managed resources. What is a managed resource? It's the lowest level of abstraction to manage state. It represents an object under the control of Crossplane, and it can be anything that exposes an API. How does that look like? So, for example, you have an S3 bucket. On the left-hand side, you see how it looks as YAML in Kubernetes. It has ACL private, it has a location constraints, it has a tags, and on the right hand, you see how it looks on the cloud provider. Just pretty much the exact same definition. Further, if you describe the object in Kubernetes, you will see its status. So Crossplane puts all the state which it finds on the cloud provider into the status of the objects for you to query. If you describe that object, you can see its events. So here, it just successfully created external resource, all good. So this is the reconciliation loop I was talking about. And on the left, you have the actual object you want to apply. You send the request against the API server. Then the S3 controller picks it up, watches it, and makes sure that your bucket looks exactly like you want it on the cloud. And a nice thing about it, if someone with admin access goes and changes something to the bucket, Crossplane will just come and roll it back. Next up, providers. Because we talked about like controllers running custom logic, but these controllers, you don't need to write them yourselves. They are provided by what we call a provider, and this one installs custom resources into your cluster. So if you would list all series in your cluster, you would find there, for example, bucket policies, and so on, all which is created by the provider as a custom resource for you to consume. We have lots and lots of providers. It has been grown over the years, and I think there's nowadays almost a provider for everything you can imagine. Just to see a few on one picture here. So let me do a quick demonstration how it actually looks like. Is this big enough? Yes? No? No? How do I actually make this bigger? Huh? Shift plus. Huh. Ah, thank you. Is enough? So good. This is just an install script which I already executed. It pretty much just creates a kind cluster and installs Crossplane to it and installs a few providers. Providers look like that. They're also, like everything else, YAML, which you just fire against the Kubernetes API, and Crossplane will do all the rest. So here we have S3 provider and SNS provider. So how does that look like? So here, I'm in the wrong folder, sorry. So here's a very simple representation of the bucket. It just like has a name and a region. So now if I can just, KL is my alias for kubectl, and I just give it the bucket, and I apply it. Then I query Kubernetes API for the bucket, and I see it's not ready yet. Let's describe it. Oh, I actually don't need a name, because I only have one. Oh, it's already done. So let's check the cloud. Refresh. Here you see it created our bucket. All good. So what happens if I delete this? Of course, it's going to be deleted. Takes a bit because Crossplane waits until it's actually deleted. If I refresh the page, we get an error. Bucket doesn't exist anymore. Nice, exactly what we want. So next up comes what we call a composition. Because exposing these objects directly is not really what you want, because when you talk about a bucket, it might be pretty simple, but we're talking about a complex set of objects. Like you don't want to give your developer just the right and option to create an RDS instance with all the knobs to turn and all the settings to set. It's just like it kind of misses the point. We want to give a simple abstraction so that developers just can create a database and it's ready to use. So that's what a composition is doing. Inside of the composition, you can write functions which support any language. You also don't need to write the function themselves. There's like plenty of stuff out there to use, but more on that later. So on top of that, we have the XRD, like composite resource definition. This actually defines what it is you want to expose to your developer. And once you create that, Crossplane will create a custom resource definition for you in the cluster for your developers to consume. How does it look like? So here's a simple composition. It just references the composite resource definition. That's the schema of the database you want to expose. And here you have what we call a pipeline. It's just a set of functions, and they're going to be run in sequential order. All they do is output YAML, modify YAML. So at the end, in goes nothing, and out comes YAML. Did I already talk? Okay, cool. Yeah, here you see the custom resource definition. You give it your API group, like your company can be example.com in this example, and the group is database. And what you're providing here is a NoSQL, and what I left out here is the Open API schema, because you can define whatever you want there according to how you would usually create custom resources in Kubernetes. The next step is configurations. Once you build your composition and once you define how to expose this to your users, you can actually create what we call a configuration, which is nothing else than an OCI image containing your composition, containing your custom resource definition, and you can package that thing and publish it through your different stages. Like you can first roll it out to dev, then to stage, then to prod. You can share it, you can publish it in the internet. We also provide configurations for you to consume, so you can have a look, but more on that later. So the last missing piece in the picture is when we enter user space, I would call it, where you actually have a developer requesting a small Postgres DB. And how does that look like? Well, in this example, very simple, because all we give in the user to adjust is a size where you can have small, big, or whatever you define. And the important thing is that you map it to your own opinionation. So if you want to have like an M4X large, and that's what a large is for you and your company, you can do that here. And if AWS changes something, you can change it behind the scenes for the user instead of requiring them to update all their manifests. So we talked a lot about these compositions, but how does this part actually work? We know there are functions and stuff, but let's have a closer look. So functions run, it's just a pipeline of simple functions which compose your resources. So they can be written in any language of your choice with your unique logic. And they provide a sweet spot between no code and building an entire controller from scratch, because that's very hard. And they focus only on your platform needs, and Crossplane behind the scenes does all the heavy lifting. So you don't want to go and set finalizers, owner references, and do the reconciling on your own. You just define what you want, and Crossplane does all the rest for you behind the scenes. It's important to note that functions have graduated. So in the past, we had like some native patch and transform functionality, and we decided to go all in on functions, and that's pretty much the de facto standard nowadays, how you compose resources with Crossplane. So if you ever used Crossplane before and you felt like your hands were tied when you're working with patch and transform, this is no more. Anything is possible now. So how can you start using functions? Well, you don't have to write any code. The community has built a whole ecosystem of reusable functions for you to consume. So you can just directly pump them into your compositions and you're good to go. But if you want to actually satisfy some more complex needs, or you have some very custom logic, nothing stops you from actually writing these functions yourself. So you can choose anything you like there. So you can use higher level configuration languages, maybe Qlang, maybe KCL, or you can go like full low level and write everything in Golang if that's what you need, or you can even mix these things, because everything is just a step in this pipeline. Let's look at some examples here. So most familiar is Go templating. Here we just create a list of access keys provided by a count of resources we have. We have KCL, where we create EC2 instances based on a set of regions. Here we have an example where we construct an IAM policy based on a list of ARNs, a config map with pkl, and last but not least, we create a bucket completely just with Golang. Okay, let's show you how this actually looks in action. So let's start with the composition. So here we're calling two functions. We're calling one function, sorry. It's called patch and transform. It's like our traditional patch and transform logic, which we have. But now that we're all in on functions, we use this as a modular thing in our system. And so you can just use it like you used them before. And all we do here is we provide a value spec team, which we forward to a list of tags. Let me actually show you the example, how it looks. So this is what you would give to your developers. So you have spec team, my team, and in the composition, we take then that and use it as an input for a set of tags, for an S3 bucket, and a topic. So this abstraction wraps both of them. In the definition, we see like it's a very simple schema, just providing one required field spec with another property called team. So now we can first we check the cluster for existing compositions, XRDs, nothing there. Okay, so we apply ours. And the definition. And we're ready to go. We can now apply this example. And now we query Kubernetes API and see what's there. Say composition example, that's the type we defined. We see, oh, there's something. And a nice thing is we can now actually call a currently still beta command, which we call trace, where we say like, okay, we want to trace this object. We called it ConfigManagement Camp 25. And we see, oh, everything is available, and it's pretty much the same as before. You can describe the object. For example, the bucket. You see it's created. We can check the topic. All good. Let's check on AWS. Let's refresh this. There we go. It's created. Let's check if it actually has the tags. Team, my team, perfect. That's what we want to see. Same with the bucket. To refresh. There we go. And there we go. It has the tags. And now that we're done, we can delete it again. So that's been composition in actions. Next up is composition environments. Excuse me. So you might run into the situation where you have lots and lots of values which you don't want your users to directly specify. Maybe it's like your default region, maybe it's your VPC ID, anything else really which comes from the environment. This we try to solve by creating an object we call environment config, which you can see an example here. How to use that? Again, with functions. So in the first step, we have function environment configs, which can be used to query Kubernetes API for this environment config. You can have multiple methods of selecting them, either by name or by label. And you can even specify, like, I want to match exactly 1, I want to match minimum of 2, maximum of 3. You can specify exactly what environment configs you want to match. And then you can use it in another function. For example, here in the function Go templating, we use it to actually set something in the status based on a key in your data in this environment config. Next thing is claim communication. So we abstracted so much away, and now a user creates a claim, and something goes wrong. but they have no clue what's going on. And neither do we want to expose all the information to them. There could be so many things which fail, which are out of their control. So in order to give that a little bit back to them, we came up with a concept of claim communication, which we also solve with a function. This is how that looked like. For example, we create a Cloud SQL instance, and in case we see synced false, reconcile error, failed to create database, what we do is like, oh yeah, that's something our developers might already know because they might violate some constraint there. So we're fine to actually exposing this to them so they have a chance of fixing it themselves. So we forward it to the composite and claim, and we say, okay, database is ready as false, it failed to create, and here's your message, which contains the original error. And as you can see, you can use templating to expose all or as much of the information in the error to them as you wish. Next up is the package manager. So I already mentioned that everything here comes as an OCI image. That means like providers, functions, configurations, and the package manager allows you to declaratively manage these components. So it enables you that when you write an API and package it as a configuration, you can specify this thing depends on provider AWS S3. This thing maybe depends on provider GitLab. And when you install that configuration, Crossplane will automatically pull in these dependencies into your cluster, and you're good to go. Where can you find these? You can find this all in the marketplace. There's really lots for you folks to explore. There's, like I mentioned, many providers, many functions. There's also a set of configurations which you can use as a start if you want to write your own configurations. Just visit marketplace.upbound.io. So, next topic, because now we crafted a bunch of YAML and we just expect Crossplane to apply it to the cluster. But do we really want to go and create a database from scratch on AWS, wait 20 minutes until it's finally finished provisioning, only to see that, oh, we made an error, it's not working as we intended, it has like 1,000 gigs instead of 10 gigs, or whatever. And we really need a quicker feedback loop. How do we do this? So we can render composition. Crossplane CLI has a render command where it takes your composite resource or your claim as an input, and it runs the whole composition pipeline and gives you the YAML, which you then can inspect and see if everything as you want. Of course, this rendering supports all the options we previously talked about. So it also supports environment configs or observed data, which means if in your composition you're doing anything based on the status of the objects you generate, with this you can actually give it an observed state of the cluster and then run your logic against that state and see if your conditions still match. There's also an option to pass extra resources, because with functions you have the ability to pretty much query any other Kubernetes object and use it as a base or whatever you want to do with it in your composition. So extra resources gives you an option when rendering to actually picture that as well. This is how it looks like in the whole picture. We just feed it all into the composition pipeline. Happens automatically if you call Crossplane render, and you will get a rendered YAML as an output. So now we have a bunch of YAML. It looks like what we want to do, but are we really sure? I mean, these things follow specific schemas, and we need to be able to validate these schemas. So the validate option in Crossplane CLI allows you to do exactly that. So the schemas of all the providers which you use will automatically be downloaded when you call the validate command. And most importantly, it can be used in conjunction with the render command. So if you see, we have like the same command as before, but we just pipe it to Crossplane beta validate, give it an additional schema dir if we want to have any additional schemas which we want to check, and just write minus for read from standard in, and it will do the validation for us. So how does it look in action? So I will leave this for a second. So in case someone want to follow or do it at home, feel free to do this. It's a very interesting exercise. let's start with a basic example. So here's our input. So what we're trying to do here is we just create an object of xTenant. That's something which we defined as an example. And the composition looks like that. So all we do is like, we want to create a Kubernetes namespace for each of our tenants. And what we also want to do is, to our claim, we actually want to forward the UUIDs of the namespaces it created. So let's try that. Sorry. So you see, it's nothing else than just Crossplane render with all the parts. And if we execute it, what we'll get is hopefully a bunch of YAML. And there you go. We have 1 namespace, 2 namespaces, 3 namespaces. But wait, we said we wanted to forward a list of UUIDs to the actual claim, but it didn't happen because we didn't specify anything else. The namespaces will get created afterwards in the cluster, and we simply don't know the UUID. But what we can do is, coming to the next example, so let me just show you the command, because the composition stays the same, everything is the same, but here we give it observed. What does observed contain? Well, it just contains a bunch of YAML, and that's what we got from the cluster after applying that composition. What is this? See, it's just like an object with a status of type namespace. Perfect. Okay. Let's see if this time when we render it, we actually get our UUIDs. So namespaces still stay the same. Very good, very good. That's what we want to see. And look, it worked. Now we finally see what we want. We can actually read from the object in the cluster and simulate the whole process before we even deploy something to Kubernetes. Why does this part not work? Good. So last step, we drive it a little bit further. So what we want to do is we have an environment config which contains some values which we want to forward as a labels. So we check if env labels, then put them as labels to our object. The rest stays exactly the same. We just added that tiny little bit. And when we go here, we again have a render command. Also, this time we use a flag of include context, which will make the whole context visible to us so that we see like which extra object we pull in, what's this environment config, what does it contain. And if we execute that, we will see, okay, now here's the whole context. This is like one environment config, then we have a cluster resource which we pull in. You pretty much can reference anything you like. And most importantly, if we go up, we see everything stays the same and check the labels. Cool, we have the labels set, business unit, group, and that's exactly what we want to see. Here you see again how we actually select for this environment config. Like we want to min match, max match 1, so we want to get exactly 1. For the cluster, we don't care, we want to have as much as 10, and that's how the rendering works. No, this one. Okay, further to validate. Validate, nothing changed. Not nothing changed, sorry. Validate, we have a new composition. This is actually one of the configurations we supply for public usage. It's just a simple abstraction of an AWS network. And as you see, it supports, it provides lots and lots of resources. There's a subnet, there's routing tables, there's routes. So if we just render that, I need to go back. if we just render that, we'll get all of these resources. And there's really lots and lots of stuff to check. So what if we can go and validate it? This is what I showed before in the slides. So we render it out, and we just pipe it to Crossplane beta validate, give it the schemas, and we're good to go. So let's validate it. So we see there's 2 failures. Why are there two failures? Well, deletion policy is required, provider config name is required. Well, what do we do? So we have 2 options now. We can say like, okay, we can change it in the definition, of course, and make it not required, but maybe we actually wanted to have that required. So we can actually go and change it here. So all we do is we add deletion policy. There we have, like, for example, orphan, which lets Crossplane know that if you delete these things, because you don't always want to delete stuff if you delete objects, like you have your VPC running and you want to migrate it to another cluster, maybe you don't want to delete it. Crossplane, you can say deletion policy orphan. When you delete the object, it won't touch it. And the other one was provider config name. For now, let's keep it simple. You can just use the default config. Execute it, and hopefully we see that everything is fixed now. Yes, everything is fixed. 17 resources, 17 success cases. Validate was successful. And now if we actually push this object into the API and let the controllers reconcile it, we have a very good chance that things will actually work as we intended. But what if not? What if the validate is still not enough? We want to do end-to-end tests of that. For that, we have uptests. Uptests is a low-code E2E framework for testing automation. So it can be used for testing providers and configuration, and originally it came from the development of outbound official providers, where we used it to increase development velocity and reliability of our official providers, and it was eventually also used to test all of our reference configurations, which you can check out as a base for building your own. And it was donated to CNCF, so it's all open source, all for you to check out. There's also GitHub workflows which you can implement in your repositories, so you don't need to start from scratch if you plan on using them. Its capabilities. So uptest using Chainsaw under the hood. It's a tool written by the folks of Kyverno, and it pretty much just generates a Chainsaw test suite on the fly for you in the background. And all it really needs is example manifests as an input. Like any of these examples I showed you, perfectly fine. You just create an API, you just create your examples, you put all the properties you want to test there, and you just execute it, and it will do all that under the hood, run Chainsaw, and you will see if everything works or not. Our standard location for that is an example directory, and you can check, once again, our configuration repositories if you want to use that, because there you have a sample implementation which wraps the most complicated logic for you. It's really not all that complicated, but you need to forward a few parameters, and it's really straightforward, actually. So how does it look like? So there is 4 steps to it. It's pretty much very similar to what Chainsaw does under the hood. So it does an apply, then an update, then an import, and then a delete. And after each of these steps, it checks if all the resources are either healthy or at the end of the day deleted if we want to delete them. It supports a bunch of hooks, because sometimes you need to kind of interfere with that process, because maybe you want to clean up something, maybe you want to do some additional assertions, and you have like a bunch of hooks during different phases of the test run. So you have setup, teardown, pre-assert, post-assert, pre and post delete, and they can be controlled by an annotation directly in the manifest. So you just write an annotation, and you don't need to take care of how you forward that script to it. It will just look for it in the same working directory, and you should be good to go. It supports a bunch of helper functions. If you maybe want to create some random names, or you want to inject arbitrary values, you can do that. So now as a final demo, I will try to do the full run. Hopefully it works because it actually goes and creates some stuff on the cloud. So we're using our configuration Azure network for that. As I said, we're going to look into the examples directory. I'm going to show you how the uptest target looks like. And all we actually need to do afterwards is just configure some cloud provider credentials, run it locally, or you can also run it with each commit in a PR in your with each PR in your CI environment. Still not enough. So what do we have here? So here we just have the whole configuration AWS network. It's pretty similar to what you've seen before. There's like a bunch of objects. This is just an Azure version of it. We have a resource group, we have a subnet, we have a network. And, oh, sorry, I forgot one thing. And we use like a unified makefile across our repositories. And you can actually use that as well if you like. We have an official build module which you can implement and which supports all these options, so you don't need to write any code yourself, you just import it. And this is how we configure it. So uptest input manifest says like, okay, we want to look at examples network XR YAML, and we also say that we want to skip the import and skip the update because that's something which is more related to providers, where people would actually test the flow of creating a resource in the cluster, checking if it's healthy, and then actually, like I said, you can orphan resources, would drop it, and then bring it back and see if it imported the correct state. But for configurations, we usually don't do that. We just bring everything up and check if it's healthy. So here we just say, almost forgot, we need to provide cloud credentials. And then we run make E2E. And what I skipped at the beginning is creating this whole cluster and installing Crossplane, installing the providers. Make E2E will do all that for you. So you pretty much just export the cloud credentials. It will kick off on its own. Now we're currently installing Crossplane. We're waiting until it's successfully installed. First it does a Helm upgrade. Yeah, then it installs Crossplane, the providers. It will provision everything in the manifest. Wait until it's healthy. If it's not, eventually it will time out. And you see that you have a failing case. In this case, I hope it will just work. And let's just give it a moment and see if everything works as expected. OK, so we already reached the phase where Crossplane and the providers are ready. So we just applied the manifest. And can actually show you this setup script, which is currently running. So it pretty much just waits for our configuration to become healthy. We use the credentials to create a secret in order to configure the provider. We wait for the provider. We wait for all the pods. We wait for the custom resource definition to be established. Sorry. And then, last but not least, we create the actual provider config, which instructs the provider, Azure in this case, how it actually should access the cloud. And looks like it's now currently in the assertion phase. So it provisions this network, and now it just waits for it to become ready. If you ever worked with Chainsaw before, you might recognize the output. And here just telling us, OK, one resource is creating, the whole composition is creating, another resource is currently failing. Why is that? Because it gets a 404 not found, resource group not found. That's fine, because the resource group we are still creating. Should actually go pretty quick. Still not ready? It's most probably because I do a live demo. OK, resource group is there. Virtual network is there. It usually goes quicker. There we go. Already finished. If I scroll up, it says assert status conditions done. Okay, cool. Our object was created. We could successfully check all its status conditions. We know it's in the state we want. And now all we do is deleting it and waiting for it to be deleted. So in order to not to steal more of your time, we will leave that running in the background. And now, last but not least, community is everything. So contributors are very welcome. There's a Getting Started guide now available if you want to contribute to Crossplane. You can check out the contributing folder in the GitHub repository. You can contribute to pretty much everything. Functions are still pretty hot, so if you want to write your own functions, check it out. Docs contributions are always more than welcome. So if you're looking for a contribution, don't hesitate to contribute. Even fixing a typo in the docs, everything helps. You can check GitHub issues. They're like, some of them are labeled with good first issue if you want to get started. There's also mentorship opportunities if you like. Just reach out to us. And this is our channels where you can get involved. We take that time to check if everything deleted. Okay, cool. Everything deleted. We're good with the test. And from there on, we love to hear if you're an adopter of Crossplane. Just make a PR to add yourself to the adopters file in the Crossplane repository. And that's it. Thank you, everyone, for your attention.